So far, we have covered how many things in statistics? Only how many? How many things? Well, on Friday and yesterday, we covered 3 things. Mean, they all start with the letter M. Mean, median, mode. Okay, mean, median, mode. Today, we cover the other 3, and that's it. We're done for statistics. Okay, we cover something called range, something called variance, and something super important called standard deviation. Standard deviation. So let's just define them quickly, and then we'll do as many examples as possible. Okay. So range. Range is basically just what? How big? How big is the what? Is the how big is the difference between the what? Between the lowest value and the greatest value. Okay. So that means how big is your what? Range means what? Range just means spectrum or like interval, or how big is the difference between one point and another point. Okay. So range is the difference between the greatest and the least and the lowest. Okay. Values in a set of data. Okay. So that's range. It's the easiest one in today's lesson. Range is the easiest one of those 3. Variance is quite a process, and even standard deviation. Variance is defined to be the mean or the average. So I want you to highlight or underline this word right here. Mean means average. So average. So that's why I had to teach you average before I teach you this stuff, because average is going to be used again for this. The average of the squares of the deviation or spreading from the mean for a set of data. I know it doesn't mean much now. When we do examples, it will become super clear. Standard deviation is basically how tight or how spread out your distribution is. Okay? So the most important thing to understand is this, everyone. This is it. This is the main thing from today. The greater this number that we're going to calculate today, the greater the standard deviation, the greater the spread of data. The greater the spread of data. So for example, if I show you this, let me say that there's a distribution that looks like this. Look. And there's another distribution. Which one is wider? The one on the right or the one on the left? The one on the right. This one is tighter. This one is wider. When it's wider, it's said to have what? This one is said to have a higher standard deviation. Which means this one has a what? Lower standard. By the way, it's always called ST and DEV. ST from standard and DEV from deviation. Every time you see ST, DEV, it means standard deviation. Okay? All right. So let's actually start with the first example. Okay. Example number 1. Just find the range of each set of data. Just find the range of each set of data. What do you need to do to always find the range? What do you do with the values? What did you do with the values for the median first? Someone has to answer, because I'm not going to say anything. Yes. You count them. That's to find the average. I'm talking about the median. What do you do with the values first to get the median? Kylan? You put them from what? Least to highest. Same thing here. But the good news is here, you don't have to order them. You just have to find the what? And so I just find the difference between them. That's it. Okay. So let's see. Which one is the lowest value here? 4. Single digits is the only 9 and 8. Yep. So go ahead and say lowest equals 4. How about the highest? What is the highest in this same set? 55. Yeah, it is the highest in the 50s. 55. What do you do with these? Do you add or subtract? Do you add or subtract? No. You actually, okay, you want to see how big the range is. So you subtract the smallest from the lowest. Sorry, the smallest from the biggest, or you go big minus small. Never go small minus big, because what do you always get? I said small. Yeah, I know. What do you get when you get small minus big? You can never get a negative range. Your range also has to be what? Positive. Okay, because it tells you how big the interval is. Yes, Chris? You can, okay, let's say, for example, that I want to say, for example, you earn $10 today, and then you earn $90 tomorrow. What's the difference between those values? 80, not negative 80. That's why. Okay, so range equals 55 minus 4. How much is 55 minus 4? 51. So that means what? The spreading of the data is over 51 values. There's 51 values between the lowest one and the highest one. That's it. Literally, those questions will probably be worth 1 mark. Half a mark for finding these out, and half a mark for actually getting the right subtraction, which I hope once you get those values, you can never make a mistake. 55 minus 4. Okay? All right. Same thing for this one. Same thing for this one. What is the lowest one? All of them are double digits. So it's easier to look at the single digit first. Sorry, the first digit. We have 60, 40, 70, 80, 30, 90, 8, 7. Which one is the lowest one? The one in the 30s, because that's the lowest tens. Okay, so lowest is 37. So lowest equals 37. How about the highest? 91. Sorry, 91? Yep, 91. Done, or practically done. So range equals 91 subtract 37. How much is that? That's 54. Yes, 54. 54. Done. That's it. That's all you need to understand for the range. Literally, there's no more I can teach you about the range. Okay? Okay, now we start with the what? With the bigger process. Variance and standard deviation. Those will be the longest things we do in statistics. Okay, so let's actually look at the example. What's the example saying? In 8 basketball games, so in 8 basketball games, some team, whatever team, maybe our team, when we played in the senior basketball tournament, scored the following scores in the what? In each game. Game number 1, they scored 100 points, and then 105, 101, 103, 100 again, 99, 102, 98. Okay. Question 1. Calculate the mean. Okay, the mean is the easiest one so far. How do you calculate the mean? Or what's another name for the mean? Average. Go ahead. So I want you to write, whoops, sorry. I want you to write the word average under this. Average. Okay, how do you calculate the average of 8 values? How do you calculate the they add, you add, and then divide by, which is how many? How many values do we have? We played 8 games. We have a value for each game. So go ahead. Average equal. By the way, what's another shorter word for average? I used it once before. Say again. AVG. AVG. In many books, they actually just say AVG. AVG equal. Okay, we need a long fraction because we're going to put 8 numbers on. Okay, 100 plus 105 plus 101. Make sure you do not skip any number. 103, 100 again. Sorry, 100. 99, 102, 98. Okay, divided by whatever we have. Yes, equals. Okay, still divided by 8. Okay, let's do this one. If someone would like to help out and actually just check my work. Okay, so 100 plus 105. So in 8 games, they scored a total of what? 808 points. 800. So what's their average? 808 divided by 8. That's got to be a perfect number of what? So this team should be expected on average to score how many points in each game they play for the future? What we should always expect them to be very close about 101. Could be slightly higher, could be slightly lower, could be exactly on the mark, but they should hover around this number, hopefully. Okay? So actually, let me change this one to have more space to write. 1 second. 808 divided by 8, which is 101. That's the average. So 101 points per game is a good guess for their performance. Yes. Did anyone else add these up? Okay, hold on. Let's think about this. 100, 100, 100, 100, 100. Was that 500? With another 600? Oh, it's definitely got to be 800 and something for sure. Yep. This one is how much less than 100? How much less than 100? 2. But this one is how many above 100? 2, 3, 1, 5. The addition is definitely going to be slightly over 800. Yep. So try it again. Try it again. It's definitely going to come out to 808 for sure. So I added all of these values. I got 808, and then I divided by how many games, which is 8 games. This is a slash, by the way. Let me write it more properly. There we go. 808 divided by 8, which is 101 games. Sorry, 101 points per game. Okay, that was the easy part of the question. Now the new part for today. Okay. Now you might ask, why did you leave us such a big space for this? Because we need what? There are a certain number of steps. You follow them, you will never make a mistake. Okay, everyone. Step number 1. Step number 1. Find the difference between each point of these or each value and the what? And the average. Okay, so step number 1. I want you to write the steps here. Okay, step number 1. I'm going to write them in steps. 1. Find go ahead, find the find the difference. Find the difference between point and AVG. Okay, that's the first step. Find the difference between each point and the AVG. What's up? Scroll up, yes. Okay, all right. So I want you now to make a line. Okay, I've got rulers. Who needs a ruler? Because we need to make a table within this white space. Who needs a ruler? Anyone? No problem. You guys can share. What is it? Is this more important than math? Maybe. Okay. So the first thing I want you to do is, okay, let me think. How many parts are we going to divide this white space into? So we're going to do the differences here. And then, yeah, 4 spaces. Okay, everyone? So roughly here, here, and here. So let's do the first one. Is that a good? Yeah, that's a good line. Okay. What's my first score in the game? Sorry, what's my first game score? No. What did they score on the first game? 100 points. So I'm going to do 100. 100 minus, what's the average? 101. How much is that? What's 100 minus 101? Negative, yes. Make sure you put the negative. All right, -1. Keep going. What's the score for the second game? 105 minus 101. That would be how many? Ah, no, just 4 because it's higher. All right. 100 and I'm assuming 100. Perfect. 101 minus 101. Perfectly the average. Done. 103 minus 101 equals what? 2. 100. They went lower again. 99. Almost there. 102. Just 1 point difference. And 98 minus 101. How much? -3. Okay, everyone. So go ahead and copy these values down. It's a very easy process. You just need to know the steps. Okay. So that was step number 1. Step number 1 is to find the difference between point and average. Okay. What is step number 2? Step number 2, square those numbers. All right. Step number 2. Oops. Step number 2, square, not square root, square. Square. When you square, you multiply a number by itself, like 5 times 5. When you square root, you find the number that if you multiply by itself gives you that number. Like the square root of 9 is 3, but the square of 9 is 81. So they're completely opposite things. For example, yes. No. It's more like so the square root of 9 is you think what times what gives me 9. 3 times 3. That's what we do. Okay? What does this mean, by the way? What does this mean? Square those what? Numbers. Okay, square those numbers. Okay, let's square each number. Go down. All right. What's the square of -1? Or what's -1 times -1? By the way, when you square any number, no. When you square any number, positive or negative, you always get a what? Positive. So that means all of those numbers, when you square them, you have got to get what? Positive answers. Okay? What's -1 times -1? Just +1. You can just write 1 or +1. It's completely up to you. So I'm just going to write what? I'm going to write 1. What's the square of 4? 16. What's the square of 0? 0. Square of 2? -1 again. Same thing. 1. -2? 4, because it doesn't matter. Very good. Come on. What's step number 3? Step number 3. Step number 3 is add those and divide by 8, which really means what? Find the average. Find the average of those. So step number 3, find AVG, a new AVG. Find AVG. Let me just zoom in so I could write bigger. Find the AVG of those numbers. Okay, well, that's not super hard. How do you find the average of those numbers? You add them up and you divide by 8. Okay. Let me just make one last column here. So 1 plus 16 plus 0. I mean, you can skip the 0, but I like to write it. Plus 4 plus 1 plus 4 plus 1 plus 9. All divided by what? Let's add. 1 plus 16. Skip this one. Plus 4. 21. 22. 26. 27. 36. What's 36 divided by 8? Well, 36 divided by 4 is 9. So that would be 4.5. One more step to do. Get the square root. Find square root. What is the square root of 4.5? Yeah, 2 point. Let's see how. I don't know. Does the question tell me how many? Well, again, depending on how many decimals I ask you to keep. Apparently, I didn't ask. So, of course. Oh, my bad, everyone. Sorry. I forgot there's a standard deviation step here because I did not see this. Everyone, sorry. This part is here. Sorry. Steps, one step. My bad. Just move this here. Oh, that's not moving. That's compressing. There we go. So here are 3 steps. And here, you just find the what? You just find the square root. Okay. One question. What does this number mean? Okay. Everyone, look at the scores of the games that this team always scored. What was their score for everyone? I just need someone to read me the scores. What was the score of the first game? 100. Score for the second game? How much? 105. Score for the third game? 101. Fourth game? 103. Fifth game? 100. Fourth game? Sixth game? 99. Seventh game? 100. Last game? Do you think this team is all over the place, or are they somewhat consistent? I mean, they score between 99. Like, what's their worst score? What's their worst score? 98. Sorry, 98. What's their highest score? 105. Most of the time, they're in the what? They're in the hundreds. Are they consistent? Compared to the scores, everyone, compared to those scores, is this a big number or a small number? There you go. Because this number is very small compared to those scores, are they all over the place, or are they keeping a tight range of scores? They're keeping a tight range of scores. So are they more like this? Everyone, are they more like this? Sorry. Or that? Which one of those represents this team? This Or this one? Lower. They are keeping it what? They're keeping what? A tight range instead of a what? Spread over all. See? Okay, everyone, look. If a game score, if a team scores from here to here, everyone, eyes on the screen. If a team scores from here to here, do they have a big range or a small range? Big range. Big dip. How about here? Small range. Which one is our team? Our team, does it have a big range or a small range? It has a small range, which means it has a what? A low standard deviation. It makes sense because the number is very small. Done. So I want you to write a last statement just to explain what this means. We're going to write it here. Small number. Again, small compared to what? Small compared to what? Compared to the what? You always have to compare it to the numbers that were given in the problem. Small number. Sorry, number. Forgot the M. Small number. Means what? Means consistent performance. Done. This is how we use, how we find and use standard deviation. This is a good team. This team is always consistent. They would never go into a game and score 50 points only. Or they would never go into a game and score, although we would like them to do so, 150 points. At least you know this team is a 100-point scoring team. They're very, very close to that. Unless something major happens to the team. Of course, a huge injury, a few players leave. Some major incident. Okay, consistent performance. Okay, everyone, let's flip the page and redo a problem we did before to even explain to you further what standard deviation is. Okay. Do you remember this problem? Did we do this problem before? Carlin, what do you think? We did it. We compared Muhammad's performance on 5 math tests to Amanda's. Okay, do you remember which one was more consistent? Even by just looking at the values. Who's more consistent? Why? Look, 84, 82, 85, 79, 81. Look at Amanda's. 99, 76, 97, 74, 65. Way too much what? Variation. Let's actually see what standard deviation tells us about that. Okay, everyone, let's do the same process. What do you always find first? The mean, or what's another word? Average. So go ahead and write AVG above. AVG. Okay, let's calculate Muhammad's average. Although we did it before. So I remember it. Does anyone remember it? 82.2. But let's do the quick calculation here. So 84 plus 82 plus 85 plus 79 plus how much? 81 divided by what? Divided by 5 tests. You're right. Yes. Divided by 5. I know what it is. It was 82.2. I remember. Okay. What's my next step? You subtract what? Each mark from the mean. So you subtract each one of those minus the what? Minus this average. You can write it down or you can just write the result. Let's actually just write the results for today. Okay. So what's 84 minus 82.2? Come on. 84. Again, each one of those will be subtracted minus this. 1 point, actually, 84 minus 82.2 is very close to 2. It's 1.8. So I'm just going to write positive 1.8, which means this test was above the average. Okay, how about 82 minus 82.2? That's negative what? 0.2. Yes. So negative. Yeah, just slightly below his own average at the end. Yes. How about 85? Oh, now he's above average. His own average, not class average. 3.8. Yes. Sorry, 2.8. No, yeah, 2.8. Positive 2.8. 79. Below. How much below? 3.2. You're right. Sorry. Negative 3.2. 81. Another negative of what? 1.2. Okay. Got the mean. Got the differences. What do I do with each one of those? I what? Which means all of them will come out what? Positive. 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 You do not have to write positive. I'm just emphasizing that all of them need to be positive now. What's 1.8 squared? Anyone? 1.8 squared. It's 3.24. 3.24. Okay. What's negative 0.2 squared? That's 0.4. Yep. How about 2.8 squared? 2.8 times 2.8. What is that? Very close. Not very close, but again? No, no. I need to multiply 2.8. What you get? 7.84. That is correct. How about 3.2 squared? I know this one. 10.24. Yes. And I know this one too. It's 1.44. All right. What did we do with those numbers after? Come on, flip to the first page. What did we do with the numbers after? After we got those positives. We added together and we divided by 5 because we got the average. So let's do that. So 3.24 plus 0.04 plus 7.84 plus 10.24 plus 1.44, all divided by what? By 5. Absolutely. So you can go ahead and start adding. I'll do it right now. There we go. Okay, clean. 3.24 plus 0.04 plus 7.84 plus 10.24 plus 1.44. Divide by 5. I get a 4.56. One more step to do. What do I do with this number to get the standard deviation, like how spread my values are? One last step. I find the square root of this number, which is a very small 2 point something. I don't know what it is. Let me find it. Ready? 3, 2, 1. Oh, I bet. 2.135, 2.14 if I want to cut it here. If I want to cut it here, it would be 5. We'll bump this up to a 4. So I need you to write this now. Square root of 4.56 equals 2. What did we say? 14. Everyone, look at this number. Everyone, look at this number and look at those numbers. Is that number big compared to these or very small? Which means Muhammad is indeed what? Inconsistent or consistent? Consistent. If the number is small compared to the actual values that created it, that's a good distribution. Good is in tight range. Tight range. And yeah, look, his lowest is 79 and his highest is 85. He's keeping it in the high, sorry, not in the high, in the low 80s. Yes. In a way, yes, exactly. Yes. Okay. Amanda's performance. Same exact amount of work. So I'm going to actually zoom out so you can see that they are perfectly identical amounts of work. All right, let's do this. I'm going to do Amanda in what? In red color. All right. Average. Was the same. I worked out the numbers for her to be the same, but she is inconsistent. But you know what? Let's write it down. 99 plus 76 plus 97 plus 74 plus 65 divided by 5. I worked out the numbers to be the same average. But now let's find these. What's 99 minus 82.2? 99 minus 82.2. That is 16.8. Imagine her performance on the first test is 16.8 higher than her own average. So positive 16.8. I think it's 16.8, right? 99 minus 82 is 17. Yeah, 7. Okay, how about her second test? Ooh, she dropped below. How much below? Negative 6.6. How about the third test? Oh, she again went really high up. That would be positive what? 14.8. Oh, yeah, 14.8. Then she dropped below. How much below? 8.2. And even more below. 82 minus 65 is 17.2. Yes, 17.2. What do I do with each of these numbers to get it to be positive for sure? You square it. So positive, positive, all of them by default, positive. What's the square of 16.8? 250 something. No, not more. 260 something. 282.24. What about 6.6? Point? Oh, sorry. 43.56. Keep going. Squared. Step gotta be 200 something. 8.2. 60 u slash. Which slash? Oh, you mean here? Oh, divide. You can write the division sign if you like. Go ahead. Last one. Sorry, say again. Thank you. Okay. What do we do with these numbers after? Hmm. Exactly. You find the average of them. So I'm gonna write it down. Go ahead. 282. By the time I write it, you could be done with the calculation. Let me just squeeze this a little bit. Yes. Divide by 5. Okay. I have no idea how much that is. I just know it's got to be a much bigger number than Muhammad. 282.24. 43.56. 219.04 plus 67.24 plus 295.84 divided by 5. Whoa, 181 point what? Let's just say 58. Let's go. Actually, no. Yeah, 5. Oh, right here. Point 2. 58 we said. Yeah, 5. What do I do with this number? Come on. Last step. Square root. What's the square root of this guy? Everyone, compare this number to those numbers. Okay, is it smaller? No, is it smaller? Is this smaller than all of these? Of course it is. But who had a smaller number? Amanda or Muhammad? Muhammad had a number of how much? 2.1. She has a number of how much? 13.5. Who is more spread out in their values? Amanda. Who is more consistent? The big number or the small number? The small number is more consistent, aka the better student. Why better? Because whenever they study to achieve the same score. They don't just say, oh, I'm either going to score very high or very low. So what's the conclusion? The conclusion is, so I'm going to write the conclusion right here. Since Muhammad's, comma, standard, uh, let me, everyone, let me just squeeze this. Since Muhammad's standard, what? What's this word I'm writing? Deviation. Oh, how spread are the values? Okay, deviate means what? If you deviate, that means you go further. And it's an English word. Deviate means go further and further and further. So since Muhammad's standard deviation is much smaller than what? Amanda's. Sorry, Amanda's. He is more consistent. He is more consistent. Done. Yep, I'll zoom out. And that's all we need to know about standard deviation. It really tells you a lot about not just the average. The average only tells you a part of the story. Standard deviation tells you actually sometimes much more about the actual what performance of the team, of the student, of the factory, of whatever.